All right. All right, here we go. We'll just kind of go around the room because that seemed to work pretty well last time. So talk about these problems. Oh, we did do that. You're right. You're correct. Oh, this is much easier. Oh, okay. I feel so much better. Okay, here we go. Okay, Nathan. I'm gonna have you read. Do you have your notes? Okay, here. All right, here, I'll zoom in for you. I don't have any extras, guys.
In the not been able to solve some quadratic equations like x squared plus 4 equals 0 and x squared plus 1 equals 0 because there are no real numbers you can square to get a negative answer. Solve this issue, mathematics created a new expanded number system based on one new number. However, this was not the first time mathematics had invented new numbers. To read about other such inventions, refer to the historical note that follows problem 863. This lesson, you will learn about imaginary numbers.
Okay.
How you can do that.
It's like the whole square root of I.
That you're previously on it.
Right. Yeah. So we're going to talk about a new number called I. And correct. Yeah. So if you tried solving this, right? So thank you, Nathan, for reading. I appreciate it. If you tried solving this, you wind up getting something like this here. And that's not okay. X squared equals -4. Because if I try square rooting, here's a problem. Can you find two identical numbers that multiply -4? Not real numbers, right? Because I can't do like what? Give me two numbers that multiply -4. Like 2 times
-2.
But those are not identical, right?
No.
Or 1 times -4.
No.
So what you can do instead is something like this. What if I rewrote it as -1 times 4 and broke it off like this? Okay, that's totally fair, right? Like, for example, if I have root 36, you don't have to write this down. But how can I break that apart? Root 4 and root 9, right? Well, what's the square of each of those separately? 2 and 3, right? 2 times 3, which is 6, right? So I'm doing the same thing. I'm kind of breaking it down. John, do you probably need a piece of paper maybe, or oh, you got okay, cool, okay. All right. So what's root 4? 2. Now here's the new concept. Root -1 can be rewritten like this.
Oh,
Wait,
no.
what? Say it again.
It's an imaginary number.
We rise to I. So I equals root -1. So this just expands our solution set. That's all it does. So I don't know. That's why we write like that, because it's imaginary. I know. It's weird. So let's go through this problem here. Actually, Reggie, can you read 863, please? Since you don't want to do this. Yeah. Okay, go ahead. Okay, go read the instructions, please. Thanks.
Like the thing before?
No, just start with 863. Consider. Okay. And then what's the next instruction?
How do you undo squaring a number?
Okay, so Lincoln, go ahead.
Square.
Correct. But by the way, you have to do this as well. Here's the reason why you have to put plus or minus. If you graph y equals x squared, we know it's a parabola, right? If you graph y equals 2, we know it's a horizontal line. How many times do the line and parabola touch? So you have to have two answers. So please do not forget the plus or minus. You have to put plus or minus when you solve by square rooting. You have to do it. So you should get two solutions for part B. Now, how many x-intercepts would you have if you graph this? Of course, 2, right? Because it looks like this. There are 2 x-intercepts. That's pretty simple, right? And if you solved it, write your answers as radicals. Well, I already did that. It's over here. And if you want to write as a decimal equivalent, you can write like this. I think it's 1.414. Yeah, I'm pretty sure that's right. So if you did Desmos, that's what would happen. You would get that. Now, by the way, just as a quick aside, what if I asked you to give me this answer? If I asked you to evaluate this,
5.
good. How can you say plus or minus 5? Why did you say 5?
Oh.
That's good. This is a good question. Why? So if we graph square roots, how does graph square root look?
Oh, you can't square root a negative number.
Obviously.
Not quite. It's not. Thank you, Elise. So here's the deal. If you graph the square root function, you guys forgot. That's okay. That's how square root looks. How many outputs does that have? One. If it had two outputs, would it pass vertical line test?
No.
No. You have to guarantee it's a function. That's why when you square root straight up, just square root a number, you have to give one answer. If you solve, however, because you're looking for points of intersection, you got to give me all the points. Clearly, 863 has 2 points of intersection. So when you solve by square rooting, you got to put the plus minus. Like quad form, plus or minus b squared minus 4ac. That's why we have it. Okay. History of rational numbers. Let's skip that. So mathematicians. Let's see here. Aiden, can you read 864, please?
No, it makes sense that x squared plus 1 equals 0 is going to solve the graph of y equals x squared plus 1 has no x steps. What happens when you try to solve x squared plus 1?
Simple. You're square rooting a negative number. Hence, the answer is not real. If it's not real, what's the opposite of not being real? Imaginary. There you go. If you have an imaginary friend, anyone have an imaginary friend as a kid? No, anyone not? Yeah, I know you didn't have friends, Nathan. I know growing up. Sorry. No, just. Well, no, I'm just joking. Is that true or? Okay. Anyway, but you have real friends where you have imaginary friends. I'll just stop there. But hence the solution is not real. So the solution is not real. So we say it's imaginary. So that's what's happening there. So if you solve this, what would x squared equal? -1. Or x would equal what? Root -1. So we call it I. So I is an imaginary number. So I equals root -1. By the way, the graphing calculator does this for you. It does it for you. I'll show you where it is. It's actually really neat. So if I go to where my graph calculator is, one of these days I'll move to a new folder. Math departments. Okay. Here we go. Okay. Browse. Finish. Clear it. So if you do so you guys switch to mode. By the way, you guys probably don't know this. Under mode, it's 1, 2, 3, 4, the 7th line. You can switch it to a plus bi, where a is a real number, bi is an imaginary number. That won't matter because that's a trig. We're not doing any trig now, so it won't matter. Whether you read, I don't. If I do square roots of -1, it gives me I. There you go. So it actually will give imaginary numbers. If it's second decimal point, it gives you I there as well. So let's keep moving with this idea. Okay, history of imaginary numbers. Let's not read the history. I don't care for the history. I'm just trying to pace myself here. Okay, so we still got quite a bit to do, but we'll get through it. All right. Perfect. Here we go. So let's have someone else read. Sophia, can you read 865, please? You guys quiet, please. Great. Thank you so much. Okay, here we go. So really simple. Just square root it and put an I. That's all you do. It's really that simple. It's not that the arithmetic is actually incredibly easy. So what's root 4? 2, but there's a negative. So you say, there we go. Now this will be 6i. No, because we're just square rooting. We're not solving. When you're just square rooting straight up, you don't put plus or minus. It's only when you're solving you have to put plus or minus. Yeah, I'm sorry. Go ahead. What do you mean by inverse I?
Like if you gave us like, I know it's like an easier version of it, but if you gave us 2i, would be like, oh, that's -4.
Oh, okay. I think what we will do, I don't know if we'll do in the next unit or probably in pre-calculus, where you'll be given solutions and you have to write the equation that comes from the solutions. And I could give you complex solutions, but we're not there yet. And probably won't get there till pre-calculus. But yeah, I'm not sure if that's what you're referring to, perhaps. Yeah, like the factor it comes from. Yeah, you would have to know that eventually. Okay, so let's look at part B. So, John, so 6i squared. Now, if I equals root -1, then if I square both sides, the radical goes away, right? So I squared is -1. So when I do 2i times 3i, treat I, by the way, like a variable. Treat it like a letter. Exactly, good. -6. Because think about it. What if I had 2x times 3x? Right? If I had 2x times 3x, that'd be 6x squared, right? It's the same kind of thing. It's basically combining exponents. So now, you guys can stop throwing stuff, please. LA, I won't shut me off for C, since just caught the ball. For C, how would I multiply this out? What would be the first thing I should consider when I'm working this out? Good, PEMDAS, correct. Okay, what's 2 squared? And if I square I should get I squared also, right? So you have 4i squared times -5i. Okay, what was I squared equal to again? Up here. Exactly. So I have 4 times -1 times -5i. Let me get rid of the stuff on the bottom. So if I multiply all that out, 4, -1, and -5, what does all that become? 4 times -1 times -5. Good. You get 20i. There you go. So here's the key, guys. So you guys don't try to do too much all at once. PEMDAS, right? One step at a time. Do the exponent, do the multiplication. Don't try to do too much at once. Work from left to right, whatever you gotta do. And D is a pretty easy one. And we'll just shout to someone out. What do you think? 5i, yeah, there we go. Yeah. So yeah, it's pretty simple stuff. Yeah, that's what's happening here. Okay, so this one here. If I were to graph this one, this is good actually. This is great review of old stuff. Do you guys remember how to find the vertex, the formula for that? X equals. Look at you guys. Awesome. Wow, we haven't done this in like a few months. Okay. Well, or maybe just remember from the teacher. I don't know. Maybe it's not me. All right. Anyway, so what do you get? You get 2, right? That's the x coordinate of the vertex. How do I get the y coordinate of the vertex? What would you do? But before that, though, if you have the x coordinate of the vertex, you could plug back in to get the y coordinate of the vertex. Because sometimes you can't factor it. So if I clean this up, what do you get? After I, not quite. If no, third time's a charm. 1. Okay, good. So think about where the vertex is. Okay, the vertex right here. Is this graph opening up or down? Up or down? Up. Is it going to cross the x-axis? No. So no real solutions. Okay, so no, does not cross the x-axis. No real solutions. If I use quad form, hopefully you guys remember that. Or you can complete the square. Either way works. Actually, personally,
Plus or minus?
you're correct. Personally, I would prefer completing the square, but we'll do it this way because the instructions said so. All right. So you should have, and please don't take pictures. Thank you. You can wait till afterwards. Okay. And can you put the camera away, guys, for a moment? Thanks. Appreciate it. All right. If you work this out, you should get 4. Let me clear some space because I'm running out of space here. Let's see. Okay. So let me shift this because a shift is needed. Awesome. Here we go. Okay, guys. John, why don't you help me out here? All right. So what's inside the radical? Hold on. Hold on. Do 4 times 1 times 5. And then 16 minus 20. Good. Okay, what's root negative 4, guys? 2. Good. So you get 2 plus or minus I. That would be your solution. Which makes sense because it's not real. In fact, actually, this is where I'm going to get a little philosophical with you guys and kind of somewhat joking. We call this a complex number. Okay, guys, focus, please. Thank you. So, Alexander, can you turn around? Okay, we call it a complex number because it's both real and imaginary. What's the real number here? The 2. What's the imaginary number? Just I. So it's called complex. This is where I get kind of silly, but it's having kind of an identity crisis because I don't know if it's real or imaginary, real or fake, because both. Hence, it has a complex personality. Well, okay, I don't know. I'll stop. But okay, but anyway, it's complex. It's got a lot going on with it. So, all right. So we're almost done here. And you guys can start doing some homework. Oh, actually, we'll do the quiz shortly after that. Let's see here. Okay, so let's talk about this stuff. Actually, let's do this. If you guys can get out, because you guys need to get your computers out anyway. Why don't you guys get your computers out and start graphing this? So let's do this in your table groups. Get your computers out if it's not out already. Do this in Desmos. Give my voice a little break. Because you guys need to start practicing Desmos anyway in preparation for the quiz. Yeah. Yeah, that's fine. Because we have an odd number. You're
Fine.
Sorry, do you do computer chargers?
yeah, 100%.
Mr. Ewan, you say there's a root to the X.
What was that? Correct, right. Same thing. Actually, I think both these will have real like x-intercepts. Yeah. So guys, let's go to Desmos. And Lois, can you put the camera away, please? Thanks. Yeah, I'm gonna come around and help you guys out. All right, come on, guys. Good work. Go. Desmos, that's not email.
Why?
Desmos. Good. Stay. Get to 3 graphs. I'll check with you guys in a minute.
Wait, are the leaves like this?
Correct. The x-intercepts.
And then just take out.
Should I wear my construction gear to support sophomores? Yeah. All right. Okay. Of course, I'm wearing blue to support the juniors too. Like Samora's like so unhappy. Like, what are you doing? Did you give me the seniors? Really? I like your video. I didn't understand the senior video. I didn't understand the senior video. It didn't make sense to me. It didn't make any sense. Yeah. You want video games? Okay. All right. Yeah. Is this it out? Oh, she's right, it is. But the lobbies all look the same though. I can't tell which one's better.
The best.
Yours is good. They're all good though. I don't think they're all. That's pretty neat too.
Bro, no. We all have our own personalized jobs.
That's pretty impressive, actually. That's pretty. Well, see, construction could have done that too. Anyway. Yeah. Okay. What was that? X intercepts, yeah. Here, I can't use my mouse with my gloves on, so you can't. Okay, guys, let's come back. All right, here we go. So the vertex here. Okay, guys, wait, you're talking about what? Oh, yeah, the juniors won in 2011, right? No, in 2010, and they went back to back. 2010 and 2011. The class of 2011, they didn't slash tires. Where are you guys hearing this from? That's like such a rumor. No, no, the juniors were so sorry. The seniors were so upset that because we used to do the closing ceremony right after lunch, and then we taught 2 classes after the closing ceremony. They were so upset they just left school afterwards. They ditched their last 2 classes. They just went to the park and just left, and then they started egging people's homes. So like, Dole Pitchford's younger brother was the class president for the juniors. His house got egged.
Wow.
During and that was during ski week, because we used to do spirit week right before ski week.
Yeah, it was way earlier.
It was in March last year.
No, that's because spring break was earlier last year. Yeah. But then after the pandemic, decided to put it by spring. Yeah, because we had to cancel spirit week. Not cancel, but we had to do a kind of makeshift spirit week during the pandemic. Yeah, that was in 2021. Yeah, because we had to like do a simulcast, and it was weird. Okay, guys, I know if you guys want more history of spirit week, I could give more history, but let's do some math now. All right, here we go, guys. So you have this as your vertex. Okay, Lois, camera away, please. Thanks. No worries. I just need you to focus. I don't care. I just want you to focus. That's all. All right. So, okay, John, can back. All right. So this crosses twice. Okay, crosses twice. But this one, where is the vertex on this one? -3, comma. No, for B, 0. So that sits on the x-axis. Hence, it bounces, right? That's a bounce, as we see. So where are the roots? It's -3. The roots here are kind of weird. I think they're -1. No, it's not weird at all. -1 and -5, I think. Yeah. Okay, guys, please, thank you. Not quite, but we're just doing some learning. Pop quiz. Yeah. You'll have a chance to redo if you need to. Don't worry. I know. Does this cross the x?
It's spirit week. We can't have any of those.
And a pop.
No.
That's illegal. This worth like 5. I heard it's illegal.
Yeah. Okay. It's illegal to give a test. That's illegal. Because it's a major. Oh no. Sorry. On Thursday, because you're here late tomorrow night.
Oh yeah.
Yeah, because we can't do major science if you're here late.
Meet tomorrow too. It sucks.
Hopefully it's before 8.
It's illegal.
Okay, guys. Okay, guys. Because I want to start the quiz fairly soon. Guys? Put the ball away. No. But I just want you guys to focus. What's the vertex for this one? -3, comma 4. No, for C. You see, it's -3, comma 4. That clearly opens up, so it has no x-intercepts. So they're gonna be imaginary, just so you know. Imaginary roots. All right, guys, let's keep moving. Guys, let's focus. All right. So next one I want you guys to do, try this one here. So guys, try 868. Do some Desmos. So I'll give you guys 2 minutes. I'll check in on you guys in 2 minutes. Try 868. So Lincoln, can you get back into some work? Correct.
Section is imaginary.
Correct. Okay, so here we go, guys. I think you guys are getting this pretty quickly, so let's keep moving forward. So the graph looks like this. Do these graphs touch each other? No. So there's no intersection. Good, no intersection. If you try solving it, here's what's going to happen.
Quadratic.
Correct.
Yep.
And if you do quad form, by the way, your programs and your calculator can actually do these for you, just so you know. If you do quad form, you have 2 imaginary answers. I won't solve it because I know you guys can work it out. But what does this mean? This means we have no intersection. You have imaginary solutions. That's the connection, guys. That's what I want you guys to see. If you have no intersection, the solutions are imaginary, just so you know. Okay. So that's what we can expect for that. Just like the previous problem, I know you guys were not quite fully focused when we graphed this. What was that graph again? That was x minus 3 squared plus 4. If you tried solving it, you guys see what would have happened in the previous problem? You'd have -4, and you'd be square rooting a negative number. That doesn't work. So when that happens, when you get imaginary solutions, you have no intersections or no x-intercepts. Okay, so that's the key connection here. And we'll do one more. And then we can start a quiz. Okay. So this one. Do you guys remember how this graph looks? I know it's kind of a funny graph. Do you guys remember? Yeah. These 2 branches, correct. The second one's pretty obvious. What's the second one? Where's y-intercept? +1. Slope's -1. These also don't touch. So what kind of algebraic solutions? 2 imaginary solutions. And you can verify it by actually solving it. But if you how would you solve this by? What would you guys remember how to solve this one? Yeah, good. You guys are on it today. So you get 1 equals -x squared plus x, or I move the stuff from the right to the left, and then quad form afterwards. But if you quad form, you're gonna get some really weird stuff happening. So yeah. Okay, let me show you the quiz. Again, I will make another one if it doesn't go well. I'm confident you guys are gonna do great. You could use Desmos, work as a team. Not a problem. Here we go. Here's how it looks. Looks like this. Okay, so it's 5 multiple choice questions. And let me stop recording.